lot more people than I expected for such an early start at the weekend. Thank you for joining me. Today, I'm going to be speaking about the future of functions. But first, let me introduce myself. Hi, I'm Lorna. I'm a developer advocate with IBM Cloud. IBM Cloud is a great place to put your data and your applications. I might be biased. I'm always asked what a developer advocate does. So, a developer advocate, I spend my time in two ways. The first way is coming to events like this, helping developers understand IBM Cloud things. The rest of the time, I spend helping IBM understand developer things. So that's advocacy, helping to communicate between the developer communities and your excellent technical selves and my employers. So it is early, but would you please raise your hand if you are the kind of person who is happy to raise their hand in talks? This is cool because there's like 10 of you. And that helps me understand what proportion of the audience I'm selecting from. Of those people who do raise their hands, which of you knows what a function is? Yeah, the same 10 people. Excellent. So at least 10 people are in the right place this morning. The rest of you, I'm sorry. Okay, so I'm going to talk about functions, but that might seem like not a particularly innovative idea. There's a famous saying, everything old is new again. It applies to history, to fashion. Neither history nor fashion are my topics today. I'm going to speak about functions. I'm going to talk about why it's a good thing that so much of our new technology is actually familiar technology. It's old technology. It's established ideas, but with a new name. I think functions, they're familiar to so many of us. If you code at all, you know how to write a function. It gives us a little bit of isolation. It allows us to give some inputs and retrieve some outputs. Functions as a service is not the first time the functions have been reinvented. I've been in this industry long enough to remember when an RPC service was quite the cutting edge of how to do things. RPC services, it stands for Remote Procedure Call, and it's literally calling a function over HTTP. And it was terribly in fashion. I think it was also a really positive thing, even after new ways of building APIs like REST came into effect. Some problems are just function-shaped. And so I continued to ship RPC services and to really build on what went before. The newest reinvention of functions is serverless technology. It's functions as a service. Serverless is such a ridiculous name, right? You're going to run your functions in the cloud, but guess what? There are servers, otherwise how would this even work? It's a server-side technology. There are servers. It's like you'll also hear no ops. It's not no ops. It's really excellent ops, but offered to you as the developer as a platform. I'm definitely more on the dev side than the ops side. I can ship a function to the cloud without needing to worry about the operations, installing a web server, setting up the networking. I just ship the function. So it's no ops from my point of view, but don't worry, there definitely are ops. So what is the serverless idea? What does it mean? How do we use it? Serverless technology is where you write a simple function, you ship it to the cloud, and it will run when you tell it to run. Either you manually tell it to run or you instruct it to respond to an event. The event could be new data in a database, it could be a web request, it could be another system triggering this. Whatever it is, your function runs in response to an event. One of the compelling points about serverless is not really about technology at all. It's about cost. You only pay for a serverless action while that action or function is running. So if nobody uses your function, it never costs you anything. Actually, it will probably never cost you anything if it's not very many people using it, or you're just still at the prototyping stage. So you don't need to commit a lot of money up front. You don't need permission for a large budget. You can just ship it and see what happens. There are some limitations. They're not always talked about, but the functions are not long running. You need to write a function and that will run and then finish. And then the next time you need it, you will run it again in response to a different event. It's usually capped at a few hundred seconds, so between 1 and 5 minutes usually, depending on the different platforms. What I really like about working with serverless technology is it's so simple. We've established that everybody who can raise their hand does know what a function is, right? It's also really simple to deploy. I call it cloud simple. If you've worked with any of the other cloud platforms, Heroku, it's simple. You just push and then your function is available. A really common trigger for a serverless use case is an incoming HTTP request. It's really a great use case to write APIs with serverless technology. Regardless of which platform you use, most of them will have an API gateway, a way of setting up routes to point to your functions. I've used Amazon Lambda quite a bit. I've also used IBM Cloud Functions. I have things in both places. I use Cloud Functions more, and that's for 2 reasons. The first reason's easy. I work there, so they pay me and my hosting bills, so that's compelling. That's the first reason. The second reason is IBM Cloud Functions is actually a hosted version of Apache OpenWhisk. So it's an open source project. It's actually a cool project. It has a really nice community. It's really active. There's lots of good and thoughtful things happening in it. And I know that there are because it's an open source project. We have contributors from a few different organizations, and I know that it's active, it's welcoming, and I can trust this technology. I can run OpenWhisk on my own server platform if I want to. I can use it locally when I'm developing. And that's one thing I really like about having properly open source offerings on a cloud platform. We have a bunch on the IBM Cloud, and I can just use local open source stuff when I'm developing, and then it works the same on the cloud. So I really like that. Working with the API gateways to build an API is, again, it's a familiar pattern. If you've used any of the micro frameworks to make any kind of web-related product, if you've used Sinatra or Flask or Slim or Express, they all follow the same sort of pattern. If you read their introductory tutorials, you register a route and then a callback for what to do when a request comes in for that route. This looks really similar when you do it with the API gateway. You set up some URL config, and then for each of those URLs, you say which function should be called in response to it. This is familiar to all of us. There are even tools that convert from some of the micro frameworks to some of the serverless platforms, because the ideas are so close. When you are building a serverless application for the first time, you are building something that's kind of a different shape to some of the applications that you are accustomed to working with. There's lots of small moving parts. It's a different animal. So work on your development process. I think a lot of people dive in really quickly and then find it becomes unmanageable. Some tips I'd like to share from my own experience. To really work on your local dev tools. Maybe you don't all need this first piece of advice, but it's something which has saved me a lot of time. Add a syntax checker to your file so that you check that your code will at least run before you wait for the cloud upload time, then execute your function, then check the logs to see why it failed. If you saw my talk yesterday, you know that I write lots of different languages all the time, and the chances of each individual one being perfectly syntactically correct, fairly slim. Luckily for me, Python will ignore the semicolon that shows up on the end of the line in almost every programming language I write. But there's lots of other places where there's small mistakes can just, it's slow, it costs time. So a local syntax check. I also like to run the function locally before I deploy it, if that's appropriate. Depends a bit on what dependencies it has. But if you either set up a proper test locally, just run the one test to make sure that what you are currently developing makes some sense. It's just a function in a file. You can just scaffold something up to run it if you want to. And that can also really improve your development process and your cycle time. Don't throw away everything you already know about good development practices. You are still going to use source control, you are still going to remember that we need some security implementation, you are still going to write tests, and you are still going to deploy in a sane way. Some of the functions as a service platforms, those tools are still at the early stage, but they're improving all the time. Personally, I use my established tools. I pushed my Git repo, and the continuous integration service has a bunch of the secrets in its environment variables, and it deploys as I would from my laptop. It works pretty well for me. I want to talk a bit about architecture. And perhaps if I was a real thought leader, there would be some pictures of bricks, something meaningful here. Serverless architecture leads us to some of the existing best practice in the way that we build software. We are already aiming for reusable components. We are already considering the principles of a microservices architecture. Serverless fits really well with that. It makes us build loosely coupled components. It encourages us to refactor and to reuse the building blocks that we create. It allows different parts of our system to be independently developed, tested, deployed. Maybe the different components are owned by different teams. Maybe they're written in different languages, but still they can be together and be part of a common platform that all of us use and all of us iterate in. Functions as a service is a smaller unit than a microservice. I think a microservice might consist of some functions as a service put together being used. When you build in this way, all of those microservices conference talks that you've seen, either here or in recent years, those are the ideas that you are going to bring when you build in this way. You need to think about data, how you format your data, how you separate metadata from the data that relates to the resources we're actually dealing with. You need to think about data hygiene. How many of your components are touching which data stores? If every single piece of your microservices application calls back to your database, you'd have been better off with your monolith. That is not how you build microservices. So with the serverless functions, we take those ideas and we think about giving individual components responsibility for communicating with a specific data store, and we try to keep those contact points as small as possible so that all of our application remains scalable and loosely coupled. Within serverless, there are some tricks that can help us, some features that we can take advantage of. With IBM Cloud Functions, well, with OpenWhisk, you can use what we call packages. Packages group actions together. We can also attach parameters to packages. If you have a couple of different actions that need the same API token or some other credentials, then you can attach it to the package, probably at deploy time, and make that available to whichever actions need to make use of it. When you're building reusable components, you can write an action that links to another action. It's called a sequence. It's like a Unix command line, right? The output of one thing, and mentally I'm definitely seeing a pipe, becomes the input of the next thing. And that way you can wire things together to take in data, perform a specific task, and pass it on. So where things are similar but different, we can put slightly different things on the sequence and then reuse those common functions as a service components. If you outgrow this, take a look at the Composer feature on IBM Cloud Functions. Gives you a little bit, well, first of all, it gives you a super cool visualization of what you have, which is always great. But it also gives you some higher level logic of how you can wire things together. If you're in the Amazon space, then the Amazon Step product gives you something quite similar. So I definitely see this across the various serverless platforms becoming available. There is a danger that because there isn't very many things that you can't write with serverless, suddenly we go mad and rewrite everything this way. I want you to be successful. So I'm going to try and share my best use cases for when I think this approach really works. The first one is, I already mentioned microservices. Something which is a small application, perhaps you've built it before, maybe you're refactoring, maybe you're just super familiar with the domain. The restricted scope stops you from building something that gets too big too quickly. Start small, grow your application, but also grow your tooling and your processes as you go along. A second use case that I see really similarly, partly because we have a bunch of data science tools on the IBM Cloud, is data transformation. Whether you're dealing with a continuous stream of data or doing a one-off cleanup, import, transfer, we've looked at distributed approaches for big data processing for a long time, right back to MapReduce. Think about how horizontally scalable that is. It's the same thing. Your data operations can take advantage of this scalable compute. Because when you write a function and push it, and lots of events are trying to hit that function, the platforms just scale it up. So you get as much compute as you need. It means your data just gets processed nice and quickly. Do look out for this if you're dealing with real-time data. With serverless platforms, all of them have what's called cold start time. So if your function hasn't been used for a while, it has to get swapped onto the container platform before it runs. So you can see a few hundred milliseconds delay if that happens. So if you're dealing with real-time data, probably don't go to serverless. I've seen a few people do that and get bitten. For most use cases, it's fine, even if the user is waiting for a response. it's a reliable delay, at least on OpenWhisk. The third use case is the most quiet and the most dangerous. I think it's the one that will make the biggest difference, and it's this. Serverless technologies have a very low barrier of entry, a low cost barrier, and a low technical barrier. Literally anybody can now write low-risk, server-side functionality. No longer is this reserved for people who have full-stack knowledge or a team of back-end developers. The front-end developer, the static site developer, the mobile developer, all of these people can build small pieces of back-end functionality on demand, exactly as they need. It's not complicated, and I think it will bring an industry-wide change. Yes, the big companies build with serverless technologies. The leader, the first to market here, was Amazon Lambda, and they were solving a problem that Amazon really had. Scalable compute is a big company problem. But it's also a small company problem. It's a hobbyist problem. Ship your static site to GitHub Pages and make the dynamic contact form submit to a serverless function. All of you could build that. Lots of examples where maybe a mobile developer needs a little bit of server-side functionality to do authentication, which needs to have a server-to-server call. You can build that. You don't need to subcontract it. It's in your hands. This technology opens a lot of doors. For me, the future of functions is serverless. It is disruptive. It will change the way that we do some things forever. If you're not already working with this, somebody asked me recently if I thought it was going to be the big thing in 2018. No, it's the big thing in 2017. I'm already answering a lot of support questions and helping a lot of clients to use these features. It's here and it's ready for you to try it and to build with it. So it's disruptive in a good way. I promise, in a really good way. I think this is something that you can try for yourselves. You literally spend an hour on Monday, sit down with me in the hallway, let's build something. It's that straightforward. Follow the Hello World tutorial. Do me a favor. Build one more thing. Go a little bit beyond Hello World. I think it's something that we can all take on and really build with. I'll tweet this list of links in a moment, but just to give you some inspiration, go and try the IBM Cloud Functions. It's all set up for you. We have a free trial. Have a play. There's a tutorial there written by my colleague, James. You can work through this. Just let him or I know if you have any questions. And if you want to get in touch, I'm happy to talk to you. You can find me through the day. I'll be hanging out on the IBM booth, mostly in the breaks. And with that, I will just say thanks for your time.